This is problem 14. Fx is 6x cubed minus 7 over x to the fourth. Look, you could use quotient rule, but sometimes you have to look at the problem carefully and notice maybe it can be simplified. Indeed, because the denominator is just a monomial, I can simply distribute the division and it works well. 6x cubed over x to the fourth minus 7 over x to the fourth. Notice this is x to the power negative 1. So 6x to the power negative 1 minus 7x to the power negative 4. That is my fx. So derivative is power comes down and power reduces by 1. Power comes down and power reduces by 1, right? So let's simplify. 6 times negative 1 is negative 6. X to the power negative 2. X to the power, don't forget parenthesis, negative 2. Minus 7 minus 4 plus 28. X to the power, don't forget parenthesis, negative 5. That is derivative. Now you want derivative at 4. All you need to do is replace the x's by 4. Keep in mind, if you simply write a 4, now that's 64, negative 64. So remember to place parentheses around that entire expression, if you like, for good measure, times, right? Star. Likewise, this x becomes 4. So you have, if I simply write 4, that's 284. So parentheses and for good measure, times. All right. Next problem. Now, this is Leibniz's rule, derivative of this expression evaluated when t is negative 4. That's what this means. So first you want to find derivative of this. So that's my function. Notice independent variable t. So my function is a function of t. This is my expression defining my function. That calls for quotient rule. F over g, derivative is denominator squared, derivative of the numerator, denominator as it is, minus numerator as it is, derivative of the denominator. So going forward, derivative, take the square of the denominator as it is. Derivative of the top, 2t, denominator as it is, minus top as it is, derivative of the bottom, 2t. So notice 2t is common here. Bring it out. What's left? T squared minus 1 minus t squared plus 1. No other changes, right? So denominator as it is, 2t is outside. Open the parenthesis, t squared minus 1. Open this parenthesis, negative t squared minus 1. So that gets me t squared cancels t squared. I'm left with negative 2. So they multiply to give me negative 4t over all of this. Okay, so I cannot plug in just this because look, they are asking me to find the derivative at negative 4. So I need to find f prime at negative 4. So what am I going to do? I'm going to replace t by negative 4. So that's a fraction. Negative 4 times negative 4 over square of negative 4 minus 1. All of this power 2. All right, that power 2. So that is equal the fraction negative 4, positive 16 over 16 minus 1, 15 power 2. That's the fraction 16 over 225. Next. So next question talks about you are given f of 5 is 3, g of 5 is 3, f prime at 5 is negative 2, g prime at 5 is 3. Find f times g prime. Okay, that's easy. You're using product rule, f, g prime. So derivative of the first, second as it is, first as it is, derivative of the second. So when evaluated at 5, derivative of f at 5, g at 5 plus f at 5, g prime at 5. That's all. I'm using the product rule. Now punch in the values. F prime at 5, negative 2, g at 5, 3, and so on and so forth. That's all. So that's a negative 6 plus 9. That's a 3. Quotient rule. Quotient rule. Denominator squared, derivative of the top, denominator as it is, minus numerator as it is, derivative of the bottom. When I evaluate it at 5, this squared, g of 5 is 3 squared, numerator f prime negative 2, g 3 minus f at 5, g prime. So all of this, what is this? Negative 6, negative 9, minus 15 over 9. Okay, minus 15 over 9. Negative 6 minus 9. So 3 goes in both if you like. So negative 5 over 3. Lastly, g over f. So same story, square of the denominator and take turns. So derivative of the top, denominator as it is, minus numerator as it is, derivative of the bottom. So g prime 5, f of 5. G prime is 3, f of 5 is 3, minus g of 5 is 3, f prime is negative 2. So this is a 9, 6 plus 6, 12. Oh, I'm sorry, 9 plus 6, 15 over 9. 15 over 9 is positive 5 over 3. Okay. Now here we'll come to this problem in our next videos. Okay. Until then.